Alright, we're back again. So we're going to get back on machining this. So right now I dug up some different cutters here to try to use. So this one's a carbide cutter. Basically we got to cut the register up in here for the case to register against. This is where it's all broken out from the rod, hitting on it or whatever it was. This is the actual stock one over here. So I don't really have a diameter I can measure because this side's all torn up. Well, you got a very little lip right up in here, maybe I can measure. This case over here, there's nothing to measure from because this is all welded up and the lip's only here and there's no case up here, so you can't measure this one either. Plus it's all broken from here anyway. From when the rod broke that or someone did, I don't know. So I have no idea what this register diameter even is. So I got to duplicate something in this case. So anyway, this cutter would come in here like this. You just cut this area right through here. So I got this cutter here to use. I got this tall one right here. Need 2 hands. So there's a nice new one here, pretty sharp. So this is a nice long one, which I can use to skim the case over here. So I can cut the side of the case down right here, where the welds are over here. I use cutters like this. You also go on the inside in here, skim that out on that side. It's another reason I use a rotary table, is I can do that. And this one here is another one. So this feels like a carbide. So it's a coated carbide, same deal. You use it to cut the edge right in here where. And you can cut down here a little ways with this, but not all the way down because it's not long enough. So these are 3 different cutters that I got here I can play with. That'll work for what I'm doing. So I'm going to try using this one here. I think it might give a better finish. Alright, I'm going to mark it with my tip here, my mark hill. So this is what I use my valve drive, so let's see if it'll work on this here. So I'm going to highlight the area I don't want to cut, so if I see the mark going away, I know I got a problem. Means I'm cutting it too big. Whew. Yeah, it stinks. Okay, so that's all marked. Alright, I marked the other case half over there also. Yeah, somewhere over there. Video. Alright, so that part's done. Alright, so one advantage of the rotary table is I already have it's already all in center, so all I do is move it over back and forth this way to go into whatever diameter I want to cut. And you got a very rigid setup here versus trying to do with a boring bar or something, which would be pretty flimsy. Okay, so this one goes down a little ways. Up about there is all I want to go down. Maybe a little lower. Okay, so now I gotta get this set up to hit it. Different. I need my tools. Can't work the milling machine when you got junk in the way. Okay, there's my little small scale hat. Okay, so this is a 10 thou. Stick it in here. Go down till you hit. About there, we're hitting. Oh, shit, it comes out on 0 again. We're at 91. This is 10 thou thick. It's going to repeat to 0. That's a fluke, because I just pounded that in there wherever it went to. Okay, so it's 2 thou up. We're not hitting. Okay, now I'm going to feed it this way until I feel it hit this way. That hit right there. So 33.6 is too much. So 4027. So somewhere around 4027 by 33 we're hitting. So that's our diameter here. So I got to go until I see where it just starts to cut on this, and then I know that's my maximum number. And I also have a line over here I can go to over on the other side to go check it to see if it's hitting on that. So you have to figure out what it is on both sides and keep it the same dimension. If it's not the same, that means it's not concentric, which Harley doesn't necessarily make things concentric. You think they would, but they don't. Alright, so I'm going to get the depth first. So how deep we're going to go, and then we'll go on a diameter later. But I got to cut this all out through here, obviously, so that's what we're going to do right now. First thing we do is get some power in here. Tripod's in the way. Contact. Phase converter's on. Okay. Let's see what we got here. We're hitting on something. What are we hitting on? We can hit on the outside. I don't want to hit on the outside. Let's see if it hits again. Still hitting. Ten. You can see the mark right here it was hitting. Sure why it's touching over there, but it is. Call that 0. Feeding it this way as I'm doing this. 20. So we're at 21.8 up there right now. That number. So you can see where it hits right here, a little nick right there. And it looks like it's probably hitting along the bottom right through here. And that's because it's all this metal here when it got hit, shoved it up probably. Because I'm not hitting anywhere over here. See, that's just barely touched there. There's nothing hitting on this side over here. So I'm going to keep cutting a little bit more. See where we come in at. I go all the way around this other side and see where it's at. Once I get to 25, I'm going to stop. Went up 2 thou that way. Contact there. Two more. Still not really hitting anything. One more thou. On the bottom, now go on the side. I'm at 23 right now. Okay, so we're at 23 up there instead of 21, and we're at 5 thou here instead of 0. So we're seeing a little high spots where we're hitting here, but we're not cutting anything yet. A couple of high spots here and there. The cutting's at the bottom of the groove right through here. This whole case is bent up because when we cut it, we cut a lot off this corner. It's warped up. I think I'm good for a couple more thou, but we'll see. So I'm going to go to 25. 25. And we've got 2 more thou on this side. What do we get? Alright, so we're cutting on the bottom now. So 2 more thou. See, we got a cut on the bottom here off and on, pretty much all the way across now. And you can see how we're getting a little high spot here, here, nothing here, a little spot there and that. So I came out to 25 on the dial up there. So I'll probably want it, I can go a little bit more if I want to, but I'm going to leave it at that for now. So I'm going to go over here and see what this is on this side now. And see if we're close. Okay. Okay, let's see what's going on here. So it looks like we're cutting on diameter and on height. I backed them both off by 5 or so. See, I came up 7 on the bottom, and I came in 5 on the dial. We're at 19.9 right now over there. So here's a low spike. See, I was cutting right there, but it doesn't look like we're cutting on the back side at all. So it looks like we're going to cut deeper on this side than this side. Now, theoretically, the depth isn't really an issue as long as you don't hit on it. The OD does matter. Let's see what we get. Definitely on depth. Here's our 7. Here's here on my tool. And I'm going to go out to 3. Not cutting. That's weird. What happened? Oh, that's what happened. There's the cutter. Why is that hanging out? I have no idea. That is not what you want to be seeing when you're cutting something. Having your cutter come apart while you're cutting is not a good sign. So that is not good. It's actually pretty bad. Okay, I don't like that. Alright, we got to do some cutter maintenance and see why that came apart. I've never had a cutter come apart like that while I'm cutting. Alright, that is not good. Yeah. So it looks like this is a clamshell effect. So when you tighten one, you tighten both. So it's weird. It's definitely not good. This top screw is loose. The bottom one's the one that's working, which is top and bottom. It's reversed. Looks like it's metric. What a shocker. It's not one of those. Oh, where's my metric at? metric. It's not that either. Feels just like the one I just used. Okay, so what do you got for screws? If it's not metric and it's not American, what the hell is it? Maybe somebody's been mixing up my tools on me. It's definitely not that one. Back to American. It's American, and that is loose. That is dangerous as hell. Looks like you can flip the thing over. It's trapezoidal shape. See, that's when I let people use your tools. They don't put them back correctly. That's definitely not correct. Okay. We're going to tighten it this time. I'm going to tighten it. That's tight. It's tight this time. Someone was in there playing with that and never put it back. That could have been really dangerous. Luckily it didn't destroy anything. Very, very lucky. Usually when a cutter comes out like that, it wads up a bunch of stuff. That would have been more welding. Okay. What did I do with it? So now I get to reset this all and redo the cut. Oh boy. Nothing like doing work twice. Bottom of time. Alright, I'll be back. I'll go remark this case up.